please ask questions if you have any. I got just wanted to comment on the last training that we did. We got a pretty extensive email afterwards from an individual, and I'm not sure if he missed the orientation, but my whole part of my reason for doing this is to make sure that we get all of the question answered. So, not only am I trying to provide information, but I want to provide good information. And even if you disagree with me on something, I'm not perfect. I do the best I can, but please don't hesitate to bring something up and say, what's on your mind. It's just easier for me to deal with it. Well, I've got everybody right here. And a lot of times, most of the time, the comments that people bring up, other people want to know those answers too. So please, if you have a question, jump in, send something on the chat, and I'm more than happy to try to address that. So today's training is provided by or funded by the Northwest Energy Efficiency Alliance. And I want to thank Damon and Dylan from Integrated Design Lab for hosting this session this morning and getting everything set up. And I will try to look at the camera. I got two screens here, so I need to pay attention to the right one. So our objectives for the class, this is an indoor air quality training with a focus on fireplaces. And so as you'll see when we get into it, it's not wood stoves and pellet stoves and things. It's pretty exclusive to, come on in. Okay, Damon, how do I get up on the big screen?
Okay, there should be a remote next to you.
Yeah.
With just a big red button or green button that should turn on.
And the screen is up. Oh.
Okay, right behind you on the wall is it looks like a little outlet. Oh, looks like Kundo's got you covered.
Okay.
That should pull the screen down. There it goes.
And do I need to do anything, or what is it going to sync automatically?
It should sync automatically once it gets going. If not,
okay.
Let me know.
So objectives, again, where are the codes or the relevant codes for indoor air quality? Some ideas on how to formulate. Can you adjust the light? How do we look at formulating combustion air, and most importantly, how do we provide makeup air for exhaust fans and combustion air? And this is a pretty in-depth, that's good right there. This is kind of a deep think into this stuff. This is a really complex problem. One of probably the hardest things that I've had to address in my time as an energy person. We're gonna, it's like what I said, if you have questions or comments, please offer them. This is the best I can do. There's not a lot of strict guidelines on some of this, and so we're just going to have to talk around it the best we can and see what we can come up with. This is to me, this is very relevant to architects and engineers. And my short answer for dealing with all of this is, when you have problems related to this, is I would love to be able to tell people you need to hire an engineer or an architect, and so, with that thought in mind, as we're going through it, I think you'll understand why some of this is beyond the scope of your typical HVAC, residential HVAC guy. This is my high school reunion, 1970s. I graduated in 73. No, just kidding. But it looked a lot like this. There were only 4 of us. I graduated from a pretty small town. But we're talking about fire today. So, always try to give just a little bit of background, on where things come from. Fireplaces are very simple things. They've been around forever. Kind of started, with just a basic chimney. And then the first person to really put design down on paper was Rumford, which is actually not his true name, but that's what he goes by. He was all about heat. And so he came up with the first published dimensions for a fireplace. And it was, quite unusual in his approach to it. So we'll talk a little bit more about that. I'll show you some. And then the Dutch and English changed it a little bit. And then as it moved over to the US, they found that, just because of the way fireplaces draw and stuff, that if they moved them to the outside into the house, that they actually drew warm air out of the space. And so, kind of some early experimentation with the solar chimney effect. And I talk about big fireplaces, but if you're really curious about how big a fireplace can be, check out Queen Elizabeth's kitchen images. They got one big enough to party in. So and then the other thing with fireplaces is we knew long time ago that they were particularly drafty. And so the wingback chair was one of the solutions to sitting in front of a fireplace. It would draft so cold behind you that, it would cool you off. And so Chippendale came up with this design, and the ears at the top of the chair were actually functional, and it was to keep the cold air from going past your ears. So it was an attempt to redirect the draft of the fireplace around you, but also to capture the heat that was being reflected off the front of you. And of course, the originals were pretty uncomfortable. And so they padded them, and you still see these chairs in use today, especially in, the more, retro homes or the mansions that are being restored and stuff. But there was also quite a bit of commentary that it had more to do with women. They were designed more towards women because of the differences in how men and women dressed back in the time. And if you can kind of visualize back then, seems like guys always had coats and hats and scarves, and women were sitting there in, dresses. And so it kind of, it was an interesting topic, but that's all I'm going to get into the history of it. Is just a couple of things there. But it kind of points out that we understood from the very beginning that there was, issues with the draft part of it. So when I'm doing these presentations, the question that I get asked a lot is, especially from industry is, well, what's broken? What is it that we're trying to fix? The guys that do fireplaces around the state, most of them have been doing it forever. Some of them are multi-generational, and they really are reluctant to embrace regulations or, even additional education at some points, because the fireplaces have always worked, and that's their argument. It's like, we've never had problems until recently. So what's broken? What is it that we're trying to fix? And then the next part is who's responsible. So what's broken is a little more difficult. I'm going to start with who's responsible. And the first one is, the codes themselves. And so we have, when we're dealing with fireplaces, we're dealing with multiple codes. If they have anything gas related to them, then it gets into part 6 of the fuel gas code. All of the ventilation, makeup air, all of that is in the mechanical code. But the masonry fireplaces have structural elements. And so we have, in a lot of cases, we have different people looking at different portions of it. And this is also a reminder that anything related to the energy code is under the authorization of the building inspector. He may have his mechanical, his HVAC guys looking at it, but it's still his primary responsibility. So just be aware that we have a lot of areas of the state that, use different people for doing these inspections. And so quite possibly you're going to have 2, sometimes 3, if there's gas involved, different inspectors on it. As far as the fireplace itself goes, the person who permits and installs it bears the sole responsibility for ensuring that it works. And this is kind of where we start to get into what's broken, because when the fireplace doesn't work, as I said before, they've installed these things for decades. And so the first thing they do is point at the HVAC guy, and the HVAC guy said, "Hey, I don't even know there was a fireplace going in here, and I don't know what I'm supposed to do to make your fireplace work." And so it has to be addressed. And if it's not in the plan reviews and it's not part of the, the load calculations and the ventilation strategies, then it's going to be problematic. So what started this, we had, and we still have problems. Probably the most recent one was about 4 months ago. And what is most common is the fireplaces are backdrafting. And these are either open hearth, they're typically open hearth fireplaces with doors. And they won't light. They'll either backdraft into the room, they can't get them going, or they'll start backdrafting while they're trying to light fire and smoke comes into the room. Not everybody that buys these houses are familiar with how fireplaces work. I grew up with them, wood stoves and fireplaces, and I knew everybody in our family knew when you started a stove or a fireplace, you had to crack a window and let, get some air into the house until the draft got initiated and going, and then you could, partially close or close the window completely. But so that's kind of the first thing that happens is, we get this big rollout of smoke into the house, and then the homeowner starts making calls, and so now we're trying to address something typically in a brand new house, that really needed to be fixed while it was being built. So we have 2 sections in the residential code. One of them just says that, we have to ensure that the room is ventilated and controlled so the indoor pressure is neutral or positive. That sounds like a really simple statement, but I can tell you from experience, and I've tested hundreds of homes, I've never found a house to be neutral or positive. Under natural conditions, it just doesn't happen. I'll show you why, but every house that I've ever tested was negative, but it does vary in degrees. The other things.
Jerry, a quick question for you on that.
Sure.
When you're testing the pressurization of the house,
Okay.
what sort of instruments are you doing? Because I know blower door, you're you're pressurizing to measure leakage. But when
Right.
you say natural state, how are you determining that pressure differential?
So to keep all of my testing consistent, I always use the front door, and I'd use a standard manometer with a reference hose outside, making sure that it's not in the wind. So I have a metal tube that I suspend, usually up higher, 3 or 4 feet off the ground if I have something to hang it on. And then run the tube under the door and then test it against the inside. And so there's a test you can do to zero it out, or you can just do a common A/B test with a standard manometer.
Okay, great. Thank you.
Yes.
So when you're testing, like the natural state, you have exhaust fans like the clothes dryers and the kitchen ventilation, right? I mean, if those are off, then was that same house at a neutral point or?
No, that's what I'm saying with nothing running. So I do 2 tests. I do just a natural test with nothing running, everything off to get 1 reading. And then I do what I call worst case scenario, which is turn on everything in the house. And I've done some testing where I just do 1 fan at a time, but typically for combustion air, if we're putting some type of a draft appliance in the house, I want to know what the worst case scenario is. One of the problems is that in new houses, the dryers are never installed. And so you either have to use an inline fan just sitting on the floor to simulate it, or you run the test without it. So there's 2 tests. There's what I call natural state of the home and worst case scenario. I don't usually run all those middle.
So if you have all these things running, appliance, ventilation, then you would have a very negative.
Yes, and to give you an idea of what that pressure is, I did all of the homes in Meridian for over an extended period of time. I did almost 100 homes, and they ran between -9 and -12 pascals with the exhaust running with no dryer. The most negative house I ever tested was a fairly airtight, intentionally airtight house in Coeur d'Alene that pulled a -49.
Wow. So that essentially in the fireplace, what you're saying is like that would be sucking.
It becomes makeup air for the house. Yeah. And so this is what we're trying to avoid or trying to address is, can we reduce the negative pressure in the house, or how do we make sure there's enough makeup air in the house for the fireplace to work? Does that answer your question, Damon?
Yeah, it does. Thank you, Jerry.
And so the other part of it is in the mechanical section, and it says where exhaust fans, clothes dryers, and kitchen ventilation interfere, makeup air shall be provided. And so there's 2 sections. There's a section that's very deliberately says if your kitchen exhaust pulls more than 400 CFM, you have to provide makeup air, and gives you a set of circumstances of how it has to be located, installed, and controlled. But this is saying something much more general, and it just says, hey, if this stuff interferes, you have to provide makeup air. And so it's very subjective. And we get into it, it's like, well, how would you, if your fireplace is backdrafting, obviously it's being interfered with, right? If it's backdrafting when you're running your fans, then you have a code section. But again, it doesn't give you direct relief. It doesn't say if it's doing this, you have to do this. But it does give us a code reference. Over time, starting back to the 2009, there was a lot of art, it was flat out arguing over the way the code was written. And it used to say that wood burning fireplaces had to have gasketed doors. And when you're building, a fireplace from scratch, how do you do that? I mean, the product wasn't available. So we went back and forth on that. ICC at one point gave us a interpretation letter that we were able to circulate. Then they modified the code in 12, some more in 15. And now this is where it's at. And this is probably what it should have been all the way back in 2009. But code changes they take time. And basically it just says they have to have tight fitting flue dampers or doors and outdoor combustion air. So it's not giving us the option anymore. It's telling you new wood burning fireplaces shall have outdoor combustion air. But again, it doesn't give us a chart or a formula, for assessing that. It does say, if you're using factory built fireplaces, the doors should be tested and listed with the appliance. So you can buy prefab masonry fireplaces that just sit in place. But again, they are not an HVAC appliance. They're considered structural. And because of their weight, they have to have additional supports in the floors. And so this all falls back on the building inspector. Again, in some areas, our inspectors, really all they have to go off of is the instructions. Is it installed according to the instructions? And then there are also options on the chimney. And so some chimneys can be masonry and some can be metal. And on the ones that I've been looking at, the prefab ones, there are places where you have to use the masonry, and there's other places where you could use either one. And so that just kind of keeps adding to the confusion. I'm not going to make this more confusing, Hasdy. We're going to start tying up some loose ends here as we get into it. The ventilation rates, we used to have to reference a chart, and now they've come out with a very explicit. It just says, if you have a house that's less than 5 air changes, you have to provide whole house ventilation. That statement can be a little confusing to some people, because if you look at a whole house fan, that's much different than what we're actually looking at, which is the minimum ventilation rates. And so just know that there's the terminology here. A whole house fan, if you were to go buy one, would probably not suffice as your ventilation system. So I wish they would clarify this language on here. I tried to get it to address it when I was on this code committee, but that's still how it's referenced. The other one, for a while, we were using a ASHRAE 62.2 that said we had to have 0.35 per occupant. They've changed that formula now, and it's basically 1% of the square foot of the house plus an extra 7.5 CFM for the number of bedrooms plus one. For those of you that, everybody should be familiar with this, but most calculations, if they're based on bedrooms, they do a number of bedrooms plus one, because the primary bedroom is considered two people. And so that's why they always do the plus one, is because most bedrooms are going to be single occupant except for the primary, which is going to have two, typically two. The makeup air, this is where it talks about the kitchen. It says, or it just says, if you have an exhaust system capable of exhausting more than 400 CFM, it has to be provided with makeup air. And so these type of makeup airs are for what we normally see in commercial kitchens, but it's not uncommon for people to order these big, massive chef ranges. Some of them have 8 burners and barbecues, grills, and they're as big as a couch. And they have these huge commercial hoods over them. And the biggest exhaust system that I've looked at, as an inspection was 1,600 CFM. And in about an 1,800 square foot house, and the furnace only put out 1,200 CFM. And so we're talking about an exhaust fan that, if you're going off of the rating, could actually pump out more air than the system could even condition. Unfortunately, there's nothing that says you can't put one of these commercial type hoods in your house. But pulling that much air out of a house, for your exhaust is it's not a good deal. It's going to be very uncomfortable to work around. Anybody that's considering one really needs to go to a restaurant and ask if they can stand under the hood in the kitchen, because they're super uncomfortable to work around. They move a ton of air, and they're removing so much air that it's often not conditioned. So they're not fun to work around, but they're out there. I've seen them. 1,200 is not, uncommon in some of these bigger homes, but you have to be able to provide makeup air. And if you're not using a compensating type hood, which are very expensive, we're talking about massive holes in the walls. And I'll show you how to calculate that makeup air, or a way to calculate that makeup air. We're talking, really big holes. And so when they put in the makeup air that it calls for, these areas are super uncomfortable because they don't have a way to condition the incoming air. And so if you're running this thing in the wintertime, it can be harsh, to put it mildly. And again, there's no specific requirements for bathrooms, laundry rooms, or range hoods less than 400. All fans together contribute to the negative pressure, and they can really have an adverse effect on the natural draft appliances. That one house that I tested up north that had a minus 49, there's no kind of a natural draft appliance that would have worked in that house. And it did have a fireplace. It had a gas fireplace. And I was curious as to whether the doors were capable of sealing it, or would it actually backdraft through the doors. And so he was going to smoke test that fireplace and make sure that it was able to overcome that negative pressure. But that's kind of the extreme. So why don't they work? And so it's one of those head shakers. Usually when I get a call from somebody, it's kind of this chaotic, confused conversation. And it's like, well, we did this and we did this and we've done these before. And I don't know what's causing this one not to work. And so I have to ask them, okay, where is it? What's going on? What'd you do here? Which, we have this long list that we have to go through, or I can just go look at it. But they typically involve a significant amount of work after the house is built. And so this is kind of the purpose of this education, was to try to get in front of it and say, if you're putting a fireplace in an energy efficient home, my blanket statement is it's going to be difficult. There is no easy guaranteed way to do it. And so all I can do is tell you why it doesn't work. And then, offer some suggestions, but I can't guarantee it. So the first thing is we're dealing with thermodynamics, which is kind of, all things will be equal. And so you have a whole bunch of different things that are happening. You have effects inside the house. I'll show you some drawings on those. stack effects. The physical location of the fireplace is a big deal. And then mostly it's makeup air. Can we provide enough makeup air to make it work without creating additional comfort issues? So these are the kind of the reasons why. I'm sure you guys have seen these drawings multiple times. I try not to spend too much time on them, but stack effect is pretty simple. It just says that hot air rises. As it rises, it produces pressure up against the ceiling. And when you have pressure in one area, the law of thermodynamics says if you're pressure here, you're going to be less pressure down low. So in the winter time, you know, we have high pressure up against the ceiling, low pressure down below. If this was a 2-story house and the fireplace was in the basement, this drawing explains why it doesn't work, right? Because your pressure is up at the top, not at the bottom. In cooling, it reverses. And so interestingly enough, that same scenario, if we put the fireplace down in the lower story on this, in the cooling season, it would work because you have a higher pressure down low than you do above. And so it's going to draft fine in the cooling season, but we use them in the opposite. So just the principles of nature we're kind of fighting against. If you have exhaust fans, as is pictured here, you know, and not just one, we have one in the kitchen, one in the laundry room, one in each of the bathrooms. If you're pulling, if we're pulling a bunch of air out, you know, out up here, then again, we're going to be negative down here, right? If this is all negative inside here, then instead of this flowing out, it's going to actually flow back down because the fireplace becomes the makeup air for the fans. And so we have to provide some other source so that we're not pulling on the chimney of the fireplace. We add some wind to the mix, and I'm not going to go into a lot of detail here, and things get really confusing. And so some of the ones that we've really struggled to get to make work were houses that were along cliff edges and stuff where the wind was blowing over the top and then falling down the cliff, and so we have, you know, literally weather related events that doesn't let it work. That's kind of beyond the control of what we're able to do inside the house. And so it can get really confusing. The other things that are happening are just those things that we don't really pay attention to. Fireplace guys, they're not building scientists, you know, they do typically masonry work. And so, you know, they're not aware of all of the things that are going on and why the houses are tightening up. But beyond the code requirements, we have better windows, better doors, better weather stripping. The HVAC cabinets are sealed tighter, the ductwork is sealed tighter. And at the same time, we're putting more bathrooms, more exhaust, bigger exhaust. And so there's this whole bunch of things that are also making the house tighter, even if we're not intentionally trying to do it. And so houses are becoming tighter even when we don't try. They're still tighter. But having said all of that, is there something else that's creating the problem? And there is. Part of it is the chimney location. And so I'm going to stand up for a minute so I can kind of, I can't point these out on the computer screen if you guys are online. But in this first drawing, if you look at the top left, you can see the chimney is below the top of the second floor. And so you have more stack effect higher in the room than the chimney is. And so again, if you're positive here, you're negative here, and the height of the chimney plays a factor in that. And so on old houses, it was always almost always the chimney was higher than the highest point of the roof, and that's intentional, and it's not to keep the sparks off the roof. It has to do with the stack effect and the draw on the chimney. And so we still need the chimney to go up, above the roof line if we can. And it also tends to take some of the wind out of play. And so these are all of these chimneys in these drawings are predominantly inside the house. The other problem that we run into, and this is really, really common on old houses, is the chimney is outside. And so I've talked about it in my other presentations that concrete is a super poor insulator. And so the R value for 8-inch concrete wall, masonry wall, is 0.68. And so chimneys are typically a combination of clay bricks, some type of an inner brick, and then an outer facing, and it could be stucco. And when these are outside of the house, you could burn the hottest fire in the world. I don't think you're ever going to get that chimney warm on the outside of it. They just give up heat so quickly that they have no ability to hold it because it's all outside. And so if you go in the inside of these older homes and you take use a thermal camera and take a picture of the inside of fireplaces, they're almost always blue. They're super cold. You can put a digital thermometer on the face of them, and they're just super cold. And so trying to get warm air to go up that cold cabinet can be really difficult. And so people have found out, again, you open the window, you light a bunch of newspaper, you get that heat going in the right direction before you try to build a fire. Or you use gas logs or something, but this is one of those things that we can fix. I know that they tend to be decorative even on the outside, but they can be wrapped and stuccoed and insulated to make them work better. Ideally, and this is where I said this is a topic that is hopefully of interest to architects and engineers, the best thing to do is bring it in the house. Because if it's all warm, if it's all the same temperature of the house, you're going to have much more likely to draw properly. And you now have all that thermal mass inside the house. So it will trap the heat and transfer the heat inside the house. So whenever we have an opportunity to bring these chases or chimneys inside, they're going to work much, much better. So chimney outflows, man, talk about numbers all over the place. I have yet to find an article or a source that gave me numbers that I feel confident using. And so trying to measure a chimney outflow is difficult because you can't put a flow hood over it while you're burning a fire. You could probably build some kind of a plate and measure it, going up, but it's going to change. And depending on how much wood you got and how big the fire is, there's so many variables there that you're not going to be able to come up with an exact number. I've heard numbers from 35 CFM all the way up to 1,000. The 1,000 to me seems excessive, but I would say, I'm thinking they're probably capable of 300 or 400, but 1,000 seems really high. And so when we're trying to figure out, how much makeup air we need, one rule of thumb says we need a square inch of fresh air for every square inch of flue. A typical fireplace in an older home is 12 by 12. And so that's saying you need a 12 by 12 hole in the wall for makeup air. That's going to create some comfort issues. And so, what do we really need? And so when we're trying to look at environmental air, so this is non-assisted air, really the only design parameter that everybody agrees on is that environmental air will flow about 400 feet per minute max without a fan assist. And so if we use that 400 feet, then we can chart, on a duct calculator, then we can start looking at different sizes. So just for an example, I'll give you some other numbers here, but a 4-inch opening, a 4-inch round opening will give you about 35 CFM. So that's not going to provide enough into the fireplace. We're going to have to use quite a bit more. And the reason I used the 4-inch one there is because it's not uncommon to see 4-inch square openings inside the firebox, but then they have a heavy metal grate, or sometimes there's a lot of bricks. And so we don't get the true 4-inch. But it's a pretty common size when they're bringing fresh air into the firebox itself. So there's still a lot of discussion on, does outside air work when we put it directly into the firebox? And so just briefly, outside combustion air was introduced in modular homes. We used to call them mobiles back in the 70s and 80s. And they were marketing these houses as super tight. They used a lot of plastic in the walls. And so these are the ones that had that fan, sometimes more than one, that ran the house, that made a lot of noise, that people couldn't figure out what they were supposed to do. So they would like pull them, but that was supposed to be for ventilation. And so those original wood stoves that they were put in modulars, they just had a 4-inch hole down through the center of them. They just pop it down below the skirting and put a screen on it, call it good. So when we test those systems, what we find is that if we're putting in unconditioned air directly to the firebox, so, we can assume that most people are going to run their wood stove or fireplace in the wintertime, that piping that cold air directly into the firebox reduces the heat. And if we use the air that's already inside the house instead, we get a hotter fire, but now we have to condition the air that's being drawn in. And so it's really not a one or the other from an efficiency standard. It's what's doable, I guess, would be a better way to put it. Jim Buckley is the owner of Rumford.com. We talked about the Rumford Fireplaces early on. He's the contributing editor. He's done a lot of articles, and his articles, he's considered a knowledgeable person on this. And these are some things that he said. It says the addition of outside air has no effect on efficiency. Basically saying it's a zero game. You can do it one way or the other, but it doesn't make any difference. And so his opinion was adding makeup to the cold air return, which is something that I've supported for a long, long time. And what he's saying and the reason I quoted him, said, remember, it's radiant heat. We're not trying to heat air. So the efficiency penalty for good ventilation isn't a bad thing. So he's saying, if we need more air in the house, let's bring more air in the house. You're going to get better ventilation, and it doesn't necessarily come with a big penalty. And my testing says the same thing. There were a lot of reluctance to do these fresh air intakes when they first started doing them. And I tested a ton of them. And now it's probably the most common way out there in Idaho for meeting your ventilation rates. Yes.
So for efficiency, is it referring to the amount of fuel that is consuming, or the oxygen that is taking, or the heat screening?
The heat that's in the house, what it's doing to the house. That whether you're bringing it into the firebox or you're bringing it from inside the house itself, it doesn't affect the heat coming off of the
temperature.
the appliance. Yeah. And I mean, you would have to do some pretty extensive modeling to prove this, but if you think about the thermodynamics and how it works, if you lower the temperature in the box, less heat, you know, you get more heat out of it, but now you got to reheat the, you know, the air inside the house, but you've got more heat to do it with.
Is that because the immediately from outside air, it's too cold?
Too cold.
And he's saying if you use air from inside the house, it's already warmer.
If you're pulling it through the HVAC system, it has a chance to temper.
Yeah.
It blends with the air in the house. It's being distributed through the duct system. So you're not pulling, say you're pulling it off a gable end. By the time it gets to the fireplace and goes through the room, it's basically tempered. It's going to be ambient temperature. And so I've tested the theory. The way I did it is I put temperature monitors in the ducts closest to the furnace or closest to the outside and furthest away. And I wasn't getting cold air coming out of a duct. It was tempering as it moved through all of the system. So I want to make sure we get out of here on time, but the backdrafts are pretty easy to explain. It's just, if we don't provide some type of makeup air into the system, then it's going to use the system, it's going to use the fireplace as the makeup air. And that's where the backdraft gets started. Again, wind induced, these are whether you're up on an exposed spot where you have wind directly down the chimney, or if you're down at the bottom of a hill or next to a cliff, the wind can play a major role in it. And we call it weather induced, but this is not uncommon either. So what do we need to do? We need to try to balance that negative pressure. We can use our makeup air to satisfy the ventilation standards, which is the primary reason why most people use the fresh air intake, is that's how we're meeting our minimum ventilation rate. If we go back to that 400 feet per minute and do our calculations, we can see that if we were to put an 8-inch fresh air return in there, we could pull up to 140 CFM through that fresh air intake. I'm not saying this isn't going to have an effect on the energy. I'm just saying that it is possible to draw in a significant amount of air from outside and still be able to filter it and temper it through the duct system. You're going to pay an energy penalty, but you're going to pay that penalty regardless. If you have an open fireplace, there's no way to make it energy efficient. It's decorative and by design. And if you want it to be energy efficient, you have to do something different. They just don't play well together. Always use a barometric on your makeup air or some type of backdraft damper. Keep it up as high as you can in the returns. We want to typically keep it at least 3 feet away from the heat exchanger, so we're not bringing freezing cold air down on the heat exchanger. They do kind of blend as they're coming in there if you put it in appropriately. If you have a super big home with multiple fireplaces, then you need to look at multiple makeup air intake. And then obviously, if we don't do it right, we can create drafts. And this is the biggest complaint we get from customers, especially on kitchen range hoods, is if you have a 10-inch pipe going out of your range hood, then typically you need a 10-inch coming in. And so you're drawing in a lot of, unconditioned air through the makeup, and it can be really drafty. Typically, the HVAC guys will drop these in the ceiling And so as you're cooking, that cold air is coming right onto your back and they can feel it. It's super uncomfortable. And so I've tried to get people to look at different locations. A really good location is behind the range. And so the makeup air is pulling from behind it, so you don't feel it. A couple of other good locations is a wall grill behind the refrigerator. That's always a warm space back there. And so you could drop a wall stack down behind the refrigerator with a grill on it and pull in air there. And so, you know, some guys will do under cabinet return or makeup. So there's ways to do it. And then another really good way to do it is if your cabinets don't go all the way to the top, to the ceiling. A lot of these big hoods are, you know, have in areas that have cathedral ceilings, you could put a return on top or a makeup air grill on top of the cabinets that would be completely out of sight and duct it through the wall and nobody would even know it was there. And with a proper, either an electric louver or a backdraft damper on that, it would only open when the range hood is running. So there's ways to do it, but you have to design it. And that's the point that I'm trying to leave everybody with is, you know, this is getting into the realm where I would tell somebody, you know, if they're building a house, you know, where all of these things are a concern, you know, get somebody involved, get an engineer involved in it. And then the other thing, which is a lot easier to do, is just to, you know, use a recirc thermometer so that you can leave the system running. And this will help blend that air and avoid drafts. And this is just a really good idea to use that recirc. So what do we know at this point? We do know that HRVs and ERVs are really helpful with ventilation, but they don't balance negative pressure. That's not their intended purpose. They're kind of, you know, X amount of air out, X amount of air in. And so they don't balance. If we're already negative, we have to look at it some other way. They do have supply only systems. Unfortunately, this has been the solution on a few homes where we had to go in and put a supply only furnace into it. So it brings in all of its air from outside, reheats it for the inside. And this is where the energy efficiency comes in, because now all we're doing is heating air to be drafted out to go up a hot chimney to go out and heat the world. You know, it can get costly. One of the things I've asked some of the architects to consider is, you know, do they all need to be wood burning? I understand the ambience. I understand what you're trying to achieve, but can we, you know, if you're doing 5 or 7 fireplaces, can we make some of them gas? You know, they have pretty good effect, but I understand what I'm not trying to judge anybody or telling anybody what they're, you know, I'm not trying to fight their design. I'm just trying to explain to them that it's hard to make these things work. And then when we talked about balanced systems, this outdoor air duct or the fresh air return is considered supply. And so if you're measuring up your bath fans and stuff, and you're calculating your fresh air intake, it is possible to balance that system or get it really close with that fresh air intake. And so my first step, what I always suggest, is to increase that fresh air intake. That would be my first step. It's the cheapest, easiest, you know, no control, no homeowner interruption type way to deal with it. So if that is not going to work, then we have other options. This is a supply only fan with a heat strip in it. You can see they're not cheap. This one's $700, and then you have to have some type of a thermostat to control it. We can do it with the equipment itself. There are sensors. We have the technology today that could monitor the pressure in the system and, basically use the equivalent of an economizer to draw in more fresh air as needed to balance the pressure out. So there are some, we have all the technology and the pieces to incorporate it into a system. And my suggestion would be, if you're getting into a significant house that has multiple systems and or multiple fireplaces, this would be the right time to get an engineer involved and say, this is what I'm trying to do, and let them figure it out, because you've moved beyond the standard residential stuff. This is another option. The EPA stoves, versus just an open fireplace. These are super efficient. This would be a net positive heating thing, where the open hearth is, typically no gain because you're using conditioned air to run it. This is another really good option, and for something that if somebody's interested in, bio heat or wood heat, look at these masonry heaters. These are super, efficient. They use a lot hotter fire, but all of the bricks and stuff are isolated. And so we want to store all the thermal mass inside the house. And then there's a disconnecting layer between the bricks that allow this to, I'm not behind there. I don't have a side view, but instead of going straight up as most fireplaces do, this goes through a series of baffles. And so the little thing that looks like a doggy bed down below is the ash tray that to shovel the ashes out. And you have a pretty small firebox, and then this goes in the back of this and goes up through a series of baffles and then kind of makes a loop. And so this upper door is to be able to get in there and clean out the baffles and clean out the creosote that will build up in that upper section. So it's an inspection plate, and it needs to be cleaned, once or twice a year. But these trap, I would say probably 80 to 90% of the heat is trapped into this masonry structure now, and then it can be radiated back out into the space. So they're super efficient, and these have been around for ever. They call them Russian stove, Finnish stove. There's quite a few names for them, but these work really, really well. So if you are wanting to do an energy efficient house and heat it with wood, this is really a good option. This is a factory built fireplace where you go online and order everything. The fireplace comes as a unit. It's usually multiple pieces that gets cemented together, and then they can finish it out any way that you want. But the nice thing with these is the doors are already built and attached, and you stamp the structure in, and then your rock guy can come in and do whatever he needs to do over the top of them. So this is not a bad option. We see quite a few of these going in. So just some final thoughts. Exhaust only systems for fireplace houses, they just won't work. It's going to create too much negative pressure, and so you'll have to do some type of a balanced system. Again, always avoid the VOCs during construction and leave the house open as long as we can, get off gassing. The communication is something that gets totally missed. Most of the times where this has become a problem, the fireplace guy and the HVAC guy never talked until there was a problem, and now the house is built. Now we're trying to fix it. Again, I'm not here to judge anybody or tell you not to do something. And so aesthetics, especially in custom homes, that's the key. That's what we're after. But while we're trying to get a nice design, we shouldn't forget about comfort, and we can and should address it. And so that's it. Questions, comments? Yes.
So you mentioned that you tested a lot of homes for the pressure inside the house.
Yes.
I mean, are you suggesting that the average house, the fireplace, it's not built right maybe, and the average house with a fireplace has issues that need to be resolved?
Yes.
So the majority of them have issues.
Yes.
Backdraft issues.
Yes.
So how would you approach an existing home, and let's say a house built in the 1920s with a backdraft issue that everything's built, historic home, what would be the first thing that you look into?
So the first thing I would do is bring in additional makeup air.
Okay.
And then I would look at reducing exhaust. Are the fans adjustable? So a bathroom, for instance, can be 20 CFM continuous or 50 CFM intermittent. And so if you're doing this as a remodel or, redoing it, would we look at continuous fans versus intermittents to try to pull that total load down? We don't want to have a really big range hood. We want to keep that down to 200. So yeah, there's things like that we look at the pull on the house, and we also want to seal anything in the ceiling, because that's what's creating that pressure. If you have a lot of stack effect and you have a lot of holes in the ceilings and that heat can pass, then you have the loss there. And so we look at where, our losses are. If the house is super leaky, which in old houses, the foundations are typically really leaky, we may not want to seal all of that. That may create a problem. So I guess what I'm trying to say is fireplaces in tight houses, it's not a good match. We can make them work, but we can't make them energy efficient. Unless we put doors or really the best thing to do is, again, look at a prefab, look at something with tight fitting doors on it, outside air as much as we can. But yeah, in historical homes, the air sealing can create some issues if we don't address it. They do make residential economizers now that can be preset to pull a specific amount of air, but they don't make like a rooftop system that can temper it and cool it. I need to rephrase that. They actually do. They make residential fan coil units, but they can be quite expensive. And so the worst of this house is a very, very expensive house. We ended up putting in an auxiliary heating system that was supply only, pulled in all the air from outside and on a pressure switch. And anytime the house got negative, it kicked itself on, and it added heating and cooling as needed, but it was turned on with the pressure switch.
Thank you.
Okay. Anybody else?
Oh, thanks, Jerry. Really appreciated it today.
Thank you. I wish I had the perfect cut and dried formula for this, but like I said, it's not that easy. I guess the only positive thing I can leave everybody with is we can fix it, and we have been able to fix every problem that I've worked on. We've been able to fix it. It's just, it costs money and some frustration.
I had one more question. A minute. When I was looking at we had a graphic that we were sharing for you, Kevin, and talking, right? And it had it showed it was two sections to a fireplace, and one of them had kind of the long system. But that's what we call it where I come from, where it kind of goes forward and then it does a bit of a loop
Right,
and it comes out. And the other one was a straight up, and
right.
it kind of said bad, good type of thing. Why is the long not a good idea?
So that was what Rumsford did. That's what he changed, is prior to him, everything just went straight up. And then we came in and we started, they call it a smoke shelf or smoke chamber, where we try to choke it down and make it harder for the air to go around. And if you look at it, it all seems to make sense. If we have a shelf, it's going to keep the cold air from, coming straight down and leaking smoke out. But what they were trying to design doesn't overcome what's really going on. So it looks good in theory, but that's not what the problem is. The problem is negative pressure in the house, chimney's not in the right location, things like that. So that shelf type fireplace, those tend to perform much, much worse smoke wise than just a straight up chimney. And so almost every modern prefab that you look at, there's no smoke shelf. There is a straight flue, either a octagon or a rectangle that goes straight up with a damper in it that closes, and they've done away with the smoke shelf. And it's just, I don't know if they were trying to maintain some of the heat in the house from going up, but those are, that's just the problems that are inherent to
So
fireplaces.
where I come from, we always build the barbecue sets, grills with something like that.
Mhm.
And the idea is always that it keeps the smoke away from your face.
Yeah,
But those are outside,
right,
right? So I guess the pressure is not a problem there.
right. As soon as the heat starts moving up, you're good. It's golden.
Yeah, and that's, and I'm building a grill right now. And I'm trying to decide if I want to go through trouble having to build this shelf thing.
The smoke shelf?
Yeah.
I don't think you need it.
It doesn't make a difference.
That's just me.
Yeah.
That is, you're asking for an opinion, so.
Yeah.
I would say, no.
Okay, well, thank you.
Yes. Thanks, everybody.